Hi,
Cool.
Stefan.
Hello. Hello. How many are you right now?
3, 4, 6, 7. 7 of us here at the moment. There will be some stragglers, I'm sure. And we're about
Okay,
to go.
cool.
Oh, we're
We're
already
live.
public. Yay! Hi, guys.
Are we public?
Yeah, this is on Google Plus channel.
All right, let's get started then. So, hello
Yeah, thank you very
everyone.
much, Stefan. The microphone is yours. Please go ahead.
Sorry?
Please go ahead.
All right. Yeah, so this talk is called Intro to Game Development with D. It's not anything fancy. I'm not an actual professor. I think the person who wrote this slides must have been drunk at the time of writing. So, a bit about myself. I've been a computer nerd for as long as I can remember. I've been a programmer since I was 12, starting out with, I believe, QBasic and some C++ and stuff like that. Eventually, I studied computer engineering at the University of Linköping in Sweden. In September 2013, I started working at Sociomantic in Berlin as a D1 developer. We're currently transitioning to D2, which we've been doing for a while, but it's really happening now. I've been a hobby D2 developer since about 2014, doing some projects here and there in my spare time to see what we can do with the language and for learning purposes and just for fun. As a disclaimer, I'm not an actual game developer. I only just dabble in these things for fun. So if there's any actual game developers in the room, you'll probably see some strange things going on here. The aim of this presentation is to show that it's possible to make games with D. I intended it not to be something fancy. The structure is sort of, if I'm a basic to intermediate level programmer, how can I start thinking about and reasoning about how to get into game development from starting with the very basics. To do that, I will show a step-by-step process, how you can go from displaying what is an empty window to having a more or less complete application that has basic elements of a modern computer game. In this case, that means displaying some graphics and handling user input via the keyboard. After that, I will show some illustrations of some old projects that I've made using this approach, just to show it as possible. I won't show the whole process of going from an empty window to a full game, because that would probably take weeks. And hopefully this will inspire some of you to create your own games. So the environment we will use is, we will use Dub, which you're probably familiar with, the language package manager. As you probably know, dub.json contains the project configuration where you can set up your dependencies and things like that. To start writing games, we will use Derelict's bindings to a library called SDL, which is a C library, which provides you with functions for creating windows and displaying graphics and handling keyboard input, playing sounds, network stuff, things like that. Right. If you have any questions, just feel free to interrupt me. I don't know if I can hear you in the back all that well, but yeah. So let's just right in.
Hey, there's a question, Stefan.
Yeah.
SFML versus SDL, have you?
Sorry, I can't really hear you.
It was more modern, but
Maybe step up to the mic. The question was SFML versus
SDL. Yeah, I personally use SFML because I thought it was more modern. But what's your take on this?
I've never actually heard of SFML. Like I said, I'm not a game developer. I just used SDL because it's a fairly popular library that a lot of people have heard of and a lot of people are probably familiar with. There's a lot of documentation and tutorials available for this one online already. But I'll definitely look into SFML at some point. Right. So, first thing we want to do to start getting into this is create a window and display it for a few seconds. It can be done in a few simple steps. First, we need to load Derelict's SDL bindings. We need to initialize SDL. We need to create a window. Then we wait a few seconds and then we'll free the resources, destroy the window. Last part is probably be considered optional at this point because the operating system should take care of that for you when you exit the program. But since we're good programmers, we will do some manual freeing of resources here. So let me load up the appropriate commits. Wait, this is the completely wrong repository, sorry.
Stefan, we can enjoy a larger font more.
Yes, I will definitely zoom in a little while. Just let me
Make a full screen.
Also for the recording.
There we go.
Yay!
See this?
Yep.
Okay, perfect. So we import some simple Phobos libraries that we need, some exception handling, and some string functions. We need string because, like I said, SDL is a C library, so we need to use this function toStringZ to convert these strings into C strings when we call the SDL functions. So to import SDL, we simply import derelict.sdl2.sdl. Initializing SDL is done simply by calling this function, derelict SDL2.load. Or actually what that does is it loads the dynamic library files and creates bindings to the functions that are available there. The actual initialization happens here when you call SDL init. And for simplicity's sake, we want to initialize everything. In case this didn't work, we enforce that the return code of SDL init is 0. If it's not, then the program will simply exit and crash. Next step is to create our window. Like I said, we need to make use of C strings here. So we take this string literal and SDL game written in D. This will be the title of our window. Set up some constants, the window initial position, the size of the window, and some SDL specific flags. This basically says that the window will be displayed. So we create our window here with the variables we set up, enforce that the window actually exists. We wait 5 seconds, and before we exit the program, we free the resources. Now let's run this with Dub and see what it looks like. Hey, we got a window. Can you see what I'm writing in the console here, by the way, or is that too small as well?
That's too small.
Okay, I'm not sure if I can actually zoom in on this in any decent way, but it's just simple command. It's mostly just typing dub run and git check out whatever commit I need to check out.
Okay.
So that's it for step 1. We've created a window. Next thing we want to do is draw an image of our game's hero. So in order to do this, we need to load some more bindings to a second SDL library called SDL_image. Then we need to load the image file containing the hero sprite from the disk. The nice part about SDL image is that it handles most known image formats like JPEG, PNG, GIF, whatever you can think of. Once we've loaded this image, we need to create an SDL surface, which contains things like the position of the image, the actual pixel data, and all the things we need to actually draw the image. Then we blit the hero sprite surface onto our window surface. I don't actually know what the word blit means, but it's something that is used in SDL to basically draw pixel data from one surface on another surface.
Yes, blit is bit level transform or transport. Just bit by bit.
Yeah, that makes sense, because that's what it does. It takes the pixel data from one surface and copies it onto another one. In this case, we will take the pixel data from our image SDL surface and copy them into the window surface. After that, we need to refresh the window surface. And because we're good programmers who manually free resources, we will free the surfaces before the program exits. So let's take a look at the code. So there's some new things here. First, we need to import the bindings to the SDL image library. We need to set up function bindings to them as well, which is done by calling derelict SDL to image load. This is the same as before. Here we use SDL image to load the image from disk. In this case, it's a simple image file stored in the same path as the same root path of our project folder. So we just provide the path hero.jpg. We use the image load function to create an SDL surface. We create our window as before. Now we get the reference to the window surface, so we can copy the image pixels onto that surface. We need to create some pointers to SDL rectangles. A rectangle is just a struct containing size and dimension data for a surface, basically. It contains 4 fields, the X and Y position and the width and the height. So we create one rectangle for the image we want to copy. We set it to null because we want to copy the entire image. The destination rectangle contains the information of where in the destination surface do we want to copy this image data. So to get this in the middle of the window, we set the X position to window width divided by 2 and the Y position to window height divided by 2. Now we call this blit surface function. We take the surface created by SDL image and the source rectangle, which is null because we want to copy the whole image, the destination surface, which is the window surface, and the destination rectangle containing data about where in this surface do we want to draw the image. After that, we refresh our window and wait 5 seconds as before. So now we should have something a little more exciting. We should have a window with an actual image in it. The image in this case is the hero of our game. You all see who the hero is?
Yes.
Awesome.
Who? I don't know who, but yes, we saw him.
Guy from Motorhead.
It's Lemmy from Motorhead.
Ah,
May he rest in peace.
Lenny. Lenny.
Lenny.
All right, cool. So that was step 2. Now we know how to create a window and how to draw an image in it. Now, for the next step, our code is starting to get a bit big, so to make the following feature additions a bit simpler and friendlier to do, I'm going to refactor this big main function that we have into a class with some methods, so that it's a lot more easily extensible. So we'll create a game class with an initializer method, in this case the constructor, a deinitializer method where we free all our resources, the class destructor, and a simple method to just run the game for starters. And here we are. Fields that we need to use repeatedly are simple fields of the class. We have the window, we have the surface, window surface, and we have the surface containing the data of our hero image. In the constructor, we load all the resources that we need. We load the SDL and SDL image libraries as before. We initialize SDL, we load the image from disk, and we create our window, and we load the reference to our window surface. We move all the resource freeing stuff into the destructor function, where we free the surfaces and destroy the window. And the actual game logic cannot in place here. It's still quite simple. We just copy the image data from the hero surface into the window surface and wait 5 seconds. The main function now just creates an instance of our game and runs it. Works pretty much exactly the same as before, but with some nicer, more extension allowing code layouts. So we're gonna start using some event-based programming now. This is also a bit of a refactoring step, and we will add a new massively awesome feature where instead of just waiting 5 seconds, the program will now wait for the user to quit. So to do this, we need to pull the SDL event queue, which is also how we handle user input. So what we do is we put the game logic in a loop where we see are there any new events in the SDL event queue. If so, yes, then handle them. The only event we will handle for now is the quit event, which is when the user clicks the X button on the window or presses Ctrl C or whatever. So we have some changes to the run function here. We store some state, checking if the user has quit the game or not, and we create an SDL event struct, which will hold the data about whatever events this function here, SDL pull event, finds. We pass it a pointer to our event struct, where the data about the event it finds will be written. As you can see, pull event returns 1 with our events in the queue and 0 if the event queue is empty. So we will loop the we will run this loop until it returns 0, and we will run the outer loop until the user has decided to quit. Oh, sorry, this is actually not the correct commit. That should be it, yes. So, like I said, we want to handle the quit event. So for now, we only check if the type of the event is SDL quit. If so, we set quit to true, which would cause this loop to break and the game to exit. Run it now. The game is going to keep running until we press the X button.
Stefan,
Yep.
that loop is a busy wait, right? The CPU will be busy?
Yes.
Yes, okay. So do you recommend maybe we should put a sleep some time in that loop? I don't know how people handle
no.
that.
I will show you this in the next steps.
Okay.
Because we will need to use, because we don't just want to handle events. If there are no events in the queue, we still want to update the game and handle the AI and draw things and whatever.
Okay, awesome.
So for step 5, we want to handle keyboard inputs. Now this is where it gets real. This will enable us to actually move our hero around on the game. To do this, we will use the WASD keys, as is quite common in most games these days. We will use an SDL rectangle to keep track of our hero's position, so we can just, whenever we blit the hero surface into the window surface, we can just check, we can just use this SDL rectangle to see where are we right now, where should we draw this image. So in addition to handling the quit event, we also need to check the keyboard state to handle inputs. Once something has happened on the keyboard, we will update the hero's rectangle's X and Y coordinates based on which keys we're currently down. And we also want to clear the game window between draws, because otherwise you will get like this trailing movement where the image is never quite erased. So here we are. This was actually the commit that I had mistakenly loaded before. So we store the hero rectangle as a member of the class, so we can store the data about where we currently are there. And what we want to do here is we want to handle another event type called SDL underscore keydown. If we get this event, we will check the keyboard state in this function called handle input. We do this by calling the SDL get keyboard state function. We pass a null parameter there because the parameter that you give it is an optional pointer to an integer where it will write the length of the resulting array. But we don't really need that right now. So we make sure that the result is not null. Oh, by the way, the reason we're doing this is so instead of just checking which key was pressed here, is so that we can press keys simultaneously and handle diagonal movement and things like that. So the index into this array that it returns represents the actual key that was pressed, and there are constants inside SDL for each key on the keyboard. So for W, A, S, and D, we use this SDL scan code W, A, S. For B, check if it's greater than 0, then it means that the key has been pressed. If we want to move up, we want to decrement the Y position of the hero rectangle. If we move left, we want to decrement the X position, and so on. So right now I'm not checking the bounds of the game area or anything. So as you can see, we can move diagonally, but we can also just move off the screen.
Question, does the SDL function transform into graphics like GPU operations, or
Sorry, I can't quite hear you.
like does Blit and the other SDL functions, do they translate into GPU operations?
Does Blit and
Blit and the other ones,
which one?
like update Windows Surface and Blit Surface and Silhouette.
Yeah, okay. So Blit, it copies the pixels from one surface onto another. Update Windows Surface actually draws those pixels into the window here.
You asked about GPU.
So update Windows Surface updates the screen buffer, I guess.
Does it directly do everything on the GPU?
Sorry?
SDL. SDL has the option to do software or hardware rendering.
Okay, but-
if you have support.
But it kept supporting both of those.
There's a flag for that.
Okay.
Yeah, the question was, how do we tell SDL to use the hardware support, GPU?
Oh, that is beyond the scope of this talk and beyond the scope of my knowledge of SDL. Like I said, I'm not a game developer. This is just
Okay. Okay,
me
but I think
experimenting and figuring this out. But I know, for example, I have used SDL together with OpenGL in some of my projects. So depending on which version of OpenGL you use and how you use it, if you use shaders or whatever you want, then you can use OpenGL together with SDL to directly manipulate the hardware rendering in that way. I think SDL by default uses software rendering, but I'm not 100% sure on that. All right. So for the sixth step, this is the one piece of game dev theory that I actually know. It's the structure of the game loop. This is getting back to your question before about if this is a waiting loop or if we should use sleep or anything like that. This is the reason why we use a waiting loop, because if we're writing real-time games, then even if there's no event to handle, we still want to update the game states and redraw the game, because there could be NPCs running around, there could be monsters shooting at you or whatever, and you still want to handle that even if the user is being idle. So the pseudo code for a classic game loop is like this. While the game is still running, we want to handle inputs, we want to update the game states, and we want to render the game. This isn't actually going to functionally change the game, but
So if there's nothing, there's still a busy loop that takes up CPU. There's the lead events, I think, would prevent this kind of busy.
Sorry, could you repeat that?
It's kind of similar question that Ali was asking about if the update function doesn't actually update anything, it's gonna be like 100% CPU because of this while loop, or is there a way that
If the
works?
update function doesn't actually update anything, what did you say after that?
I mean, the question is the same as the earlier one. are we ever busy waiting, or are we sleeping if there's nothing to do?
I guess that depends on the kind of game you want to write. If you're writing a turn-based game where you only play against the computer, then I guess in the update function you could add a sleep there until there is an event happening from the user. But in this game, no, and not in the games that I will show you, yeah, it will be a busy loop all the way.
Okay. And maybe that millisecond argument is the answer to our question. We'll
Yes, so what we do here is, this is the same as before, we handle the events. After that, we call the update function, which updates the game state. We get the number of milliseconds that have passed since SDL was initialized with this function SDL get ticks. This is useful because if you have a real-time game where you have objects moving at certain speeds, you want to be able to calculate like how far should they have moved for each time you call this update function. In this simple game, we don't really need to do anything right now in the update function, so it's just empty. I just put it there to demonstrate the structure of the game loop. We moved the drawing code into the render function. We clear the window and we lit the surface and we update the window surface as before. Handle the events. We have moved some logic out of this. We no longer manually check here if the event type is SDL key down. We have moved all that code into the handle function mostly for abstraction reasons, so we can handle other types of events like key up or mouse down or whatever here. So same as before. We can just move our arrow around on the screen and not try to do much. So, in order for this talk to not take forever, I've decided to just skip ahead and show you a bit what is possible. If you take this approach where you have a basic game loop, you have keyboard inputs, and you have a way of rendering graphics somehow, and show you what you can do with some quite simple additions. For example, here is Conway's Game of Life written in D. You might be familiar with this. It's a type of cellular automaton. Can you see this?
Yes.
Where basically every cell is alive or dead, depending on how many cells are alive or dead around it. And in my implementation, you can pause it by holding down space. You can randomize the grid by pressing and holding down R. And you can see new worlds appear like that. I've also created some pre-made examples like the classic Gosper's glider gun. It creates these things here called gliders. It's a classic like computer geek image. You might have seen this thing on t-shirts or something like that.
Yeah, actually, there is another one that eats these. They go in and they disappear. There's a sink of this too.
Does it have a name, this thing?
I forgot. There is a sink that grabs all of the bullets like that.
So are you
Alright,
limiting
cool.
the frame rate here? Like, can you have...
We can pause it, and we can, if I press R, it will randomize the grid again and get rid of this whole glider. Another game I've made is more of a proper game. This one actually has sound and music and everything in it, but I don't know, I don't think you'll be able to hear it. But here's what it looks like. So the game is called Dark Matter Mystery Black Body Spectrum. If anybody gets that reference, you are awesome, and I will buy you a beer at DConf. Classic space shooter game. You can hold down tab to see the objectives. You move the ship with W, A, S, and D, and you press space to shoot these space bugs. And you want to avoid those asteroids because if they destroy everything in their path, as you can see. I haven't gotten very far in this game, so once you have killed 50 space bugs, it just says that you won, and that's about it.
Awesome.
Yeah, so this is possible by writing D. So what are some next steps you can take from here? One thing you'll probably want to do is decouple the SDL code from the game logic. One thing that I've done is created a class for an SDL app that takes as a parameter a game, which is a simple interface that provides these three functions in the game loop: handle, update, and render. And this class then takes care of everything related to SDL, and yeah, you can give it whatever game you want that fits this sort of pattern. You want to make the movement a bit smoother, because as you can see it was quite choppy. And you might want to make an actual game out of what we have there, instead of just a black screen with an image of Lemmy moving around. Some things you might want to learn about if you want to get into this is collision detection. For 2D it's quite simple. For 3D you have to get into linear algebra and things like that, which gives me nasty flashbacks to university. Game state management, like how do you go from a intro screen to a menu to playing the actual game. How do you have different levels, maybe even create a level editor, things like that. Data serialization is very useful to learn about for managing and storing game levels on disk and loading them, and managing saving game states if you want to quit and get back in the middle of a game later. And yeah, that's about it for me. Sorry for my mind is a bit wandering since it's almost 4 AM here. But yeah, thank you for
very
listening.
much
Hope
for
you
doing it.
enjoyed it.
Oh, that was awesome. Thank you, Stefan.
Thank you very much. Any questions?
Yeah, actually, so does any of this simply apply for web games or even like on running on localhost, or is just not? Different?
Not with SDL, I'm afraid. I don't think.
You can convert SDL into WebGL.
Windows.
Well, if you're mixing in OpenGL with SDL, then you could apply some WebGL concepts and have a web server serve up your JSON and some of your other game logic into your web browser.
But would that actually run efficiently? Because it would run on the
Yeah.
server, so like 10 by 10, it would like 10.
Oh, you don't send the frames in.
Okay, you send the state.
You'll send some state,
Okay.
and you'll send some logic.
So you can actually do that.
So do you want to be able to run the actual game inside of the browser? Is that what you mean?
Yeah.
I don't know if that's actually possible with this approach. This is more for creating sort of Windows or Linux games. SDL is cross-platform, so you can use it for whatever operating system you want.
And same question with Android. Actually, I'm not sure what's the latest this like, Android support for G or iOS.
Sorry, could you repeat that?
Oh, so same question but with like running on mobile, like Android or iOS. I don't know what's the latest on the support on those platforms. And
I don't know much
Uh-huh.
about that, but LLVM and GDC, they have backends for that platform.
Mhm.
I don't know what work needs to be done for,
It's like the runtime is the bottleneck.
I don't remember.
Mhm.
Forums have discussions about that.
Don't think that he was much of a bottleneck for that. I know that
I mean-
you had said that LDC and GDC support that, and SDL is on it. So you might have to handle the,
But is the runtime for like work and that this is actually can run a demo program?
Adam, do you know the answer? Have you used ARM, Adam?
No, I don't know.
You don't, okay. Great.
I
Thank you
think with
for
later
letting-
SDL versions, they are trying to make SDL available for mobile as well, but I haven't tried that myself. So there should be at least be C and C++ guidance for that. But I don't see why we would use D, as long as you can compile for those platforms.
Unless there are other questions, we'll let you go sleep or go to work. I don't know which one.
Yeah, I got a train to catch in about 5 hours, so I think I'll be going to sleep.
Okay.
Thank you all for listening, and I'll see some of you at DConf, I suppose.
Thank you, Stefan. You will see some of us, yes.
Also, have a good evening then.
Bye.
Thank you.
Bye.
Stop broadcast.
You wanna-
I think so.
Right, internet, goodbye.
And let's see where